Have you ever really thought about the building you're in right now? I mean, not just how it looks, but how it works, how it breathes, how it uses energy, how it keeps you comfortable. The buildings we live and work in have this huge, often invisible impact on our lives and on the planet. So today, we're going to pull back the curtain on the science of making them a whole lot smarter.
All right, let's just kick things off with one single kind of staggering number, 40%. According to the Building Performance Modeling Handbook, that's how much of the world's total energy is consumed by buildings. That's an enormous figure, and it puts our homes and offices right at the center of the global energy conversation.
Exactly. They really are the silent energy giants of our world. We just don't think of them that way, but their appetite for energy is absolutely colossal. So the big question is, what if we could change that? What if we could design them not just to stand there, but to perform, to be brilliant? That's what we're going to explore. Okay, so to start, we really need to wrap our heads around the true scale of this challenge. Just how big are these silent giants anyway? Now, get this. We hear so much about emissions from transportation, right? All the cars, trucks, planes. But look at this comparison. Buildings are responsible for 33% of greenhouse gas emissions. That's a full 50% more than the entire transportation sector combined. It completely reframes the conversation about where our biggest climate challenges really are. So, yeah, the problem is huge. But here's the good news. We have an incredibly powerful solution. And that brings us to the blueprint for performance. It's called Building Performance Modeling, or BPM for short. And you can think of it like creating a digital twin of a building. So before a single brick is even laid, architects and engineers can run thousands of simulations on this virtual model. It's like a stress test to see how the building will handle a summer heat wave or a crowded office, letting them optimize the design for peak efficiency, and just as importantly, for the health and comfort of the people inside. And this isn't just one simple test. BPM is this whole suite of analyses that looks at the building from every possible angle. It models the total energy use, it simulates how natural daylight will move through a room during the day, it calculates the exact heating and cooling systems needed, analyzes airflow for good ventilation, and it even models how comfortable people will actually feel in the space. It's the whole shebang. Now, to really grasp how this all works, it helps to think of a building less like a static object and more like a living system. So let's take a look at the anatomy of a smart building. Every building has a skin. In the business, we call it the envelope. And this is its first line of defense, the critical barrier between that nice controlled indoor environment and the wild, unpredictable weather outside. Its performance is probably the single most important factor in a building's energy use. And this shows a great way to think about how we measure that performance. It really comes down to two key values. You want a high R value, which means it has high thermal resistance, and a low U value, which means less heat is transferred through it. BPM helps designers pick the perfect combo of insulation, windows, and materials to create a good skin that keeps the outside out and the inside in.
Okay, so let's move inside the skin. This is where we find the building's lungs and circulatory system, the HVAC. That's for heating, ventilation, and air conditioning, all the machinery that keeps us warm, keeps us cool, and supplies fresh air. BPM is crucial here because it makes sure these systems are perfectly sized, not too big, which wastes a ton of energy, and not too small, which means people aren't comfortable. But those HVAC systems aren't working in an empty box. They have to deal with the building's metabolism. Think about it. Every person, every computer, every light fixture is generating heat. We call these internal gains, and believe me, they add up fast. BPM has to account for all of it to get that energy balance just right. And here's a perfect example of just how much of a difference our own bodies make. A person just sitting at a desk generates about 66 watts of heat. That's basically like an old incandescent light bulb. But in a gym or a crowded club, that number can more than double. Now just imagine a skyscraper with thousands of people inside. You can see why modeling this metabolism is absolutely essential. So, we've kind of dissected the building, right? We have the skin, the lungs, the metabolism. But how do all these technical details connect to the biggest goal of all? How do we get from these blueprints to zero carbon? Well, first, we've got to speak the right language. The most basic metric is something called site energy. This is just the energy the building uses itself. It's what you see on the monthly utility bill. It's the energy consumed right there on site.
But, and this is a huge but, site energy doesn't tell the whole story, not even close.
To get that electricity to your building, a power plant way over somewhere else had to burn fuel and then send that power down long lines, losing energy at every step of the way. Source energy accounts for all of that. It's the true total energy footprint of the building, and it's the number that really matters for the climate.
And understanding that difference brings us to the ultimate goal, the zero net energy building. It's actually a beautifully simple idea. Over a whole year, the building generates as much clean, renewable energy as it consumes from the grid. It hits a perfect balance. It's pretty amazing. And getting there isn't guesswork. It's a clear 4-step strategy. Step 1 is conservation, using BPM to design a building that just needs less energy to begin with. Then comes electrification, switching from fossil fuels like natural gas to super efficient electric systems. Third is renewables, putting things like solar panels on the roof to generate your own clean power. And finally, storage, using batteries to manage all that energy. It's the complete roadmap to decarbonization. This entire process, all this science and modeling, is doing more than just creating better buildings. It's creating brand new opportunities, and it's fundamentally reshaping our world for the better. We are, quite literally, building the future. And a huge part of that future is jobs. The demand for professionals who can do these kinds of complex analyses is exploding. Titles like building performance engineer and decarbonization consultant, these are becoming some of the most important roles in the entire architecture and engineering industries.
And as a field that really needs a unique blend of skills, it's not just about being a technical wizard. As the source material puts it, it demands curiosity, patience, and great communication. It's about solving these complex puzzles that have a real, tangible, and, as they say, incredibly rewarding impact.
So, at the end of the day, that's the bottom line. When we use BPM to turn a simple blueprint into a dynamic, predictive digital twin, we're doing so much more than just designing a structure. We are actively engineering a future that's more efficient, more comfortable, and profoundly more sustainable. Which leaves us with one final thought. The building you're in right this second, how well is it performing?